All right, so we are going to go through problems 3 through 15, 17 to 24, and 26 to 30 in lesson 5-1. So problem number 3. So we have a over 7 times b over 2. We're going to multiply straight across. You can cancel early if there was something to cancel, but there's only an a on the top, no a on the bottom. There's only a b on the top, no b on the bottom. No numbers up top to do any kind of cancellation or simplifying, so we're going to go straight across. So it's just a times b, which is ab, and 7 times 2, which is 14. And that's it. Number 4. Now in this one you can multiply first and just combine everything basically, and then you could simplify the numbers later. Or if you notice right now that the 3 and the 30 can simplify, you can divide them both by 3. Then you can go ahead and do that canceling now. It doesn't really matter. You might as well do it now, but if that confuses you early, then you don't need to go ahead and do that. So if I do go straight across, it's just 3xy. Can't actually combine any of that. And then 30z squared. So none of my variables here are going to cancel, but 3 over 30 does simplify. I'm going to divide them both by 3, so I get 1 over 10, because if I had 3 over 30, that's the same as 1 over 10 dividing by 3. So I don't need the 1 in front of the xy, although it's not incorrect if you put the 1 there. The 30 simplified to a 10, and z squared is still there. Again, the x and the y don't simplify the z squared because they're different variables. Now you'll notice on your key, if you looked online, that key did not have the right answer. So if you're confused by that, that's just a typo in the book. That y is still there. That y doesn't go away. Okay, so for your final answer, it's going to be xy over 10z squared. All right, number 5, determine whether this equals this. Is that always, sometimes, not always true, never true? And so you can explain it in words, but ideally you're going to take 1/5 and you're timesing it by n. So what that's equal to is 1 over 5 times n over 1. And so when you multiply that straight across, you're going to get n over 5. So 1/5 times n, which is right here, is the same as n over 5. That is always true. Number 6. Same lines. Explain why this is equal to this. You could show it. You could say 3/8 x is equal to 3/8 times x over 1, which is equal to 3x over 8. Okay, and it says explain. This is good enough. If you show your work and it makes sense, it's a good explanation. Okay, number 7. Which expression does not equal the others? So if I just look at these two, I don't need to go ahead and do all the extra work like I just did here, like put the n over 1 and multiply. I'm going to get a 5n on top, and I'm going to get an 8 on the bottom. So I already know that these two are equal to each other. So I basically have to go look at the other ones and see which other ones are going to equal that. So this would be over 1, 5n over 1. So when I multiply straight across, I'm going to get 5n on top. I'm going to get 8 on the bottom, which is the same as these. So process of elimination, this is the one that is not equal to the others. But why? If I put this 8 over 1, because any whole number is over 1, and I multiply straight across, I'm going to actually multiply 8 times 5. So in order to be equal to these, I need 5 on top and 8 on the bottom. This is not going to be like that. 8's on top, 5's on top. They're going to get multiplied. So letter D is the correct answer. And if you wanted to show why, you're doing this times 8, which is 5 over n times 8 over 1. And so that's going to give you 40 over n, which is not equivalent to the others. All right, so we're going to simplify these. I'm going to show you some tricks to use the calculator for these really big numbers. So for number 8, we've got 1875 over 225. Now you could go by 25 or 5, obviously. And I'm guessing 75 as well, but let's say that you didn't know. So in the past, we would just try numbers until they both worked. So we would do 1875 divided by 25. Okay, that worked. So 225 divided by 25. Okay, that worked. Oops, 225 divided by 25. So if it worked for both, now I can go ahead and divide by 25. If I wanted to try 75, I could try that. Okay, that worked. And 225 divided by 75. Okay, that worked too. So I could divide them both by 75. But now that's a long process. We want to be able to speed this up with the calculator. So if you bring up your fraction function, so you hit alpha and then x right next to it, if you just go ahead and plug these numbers in, 1875 on top, scroll down, 225 on the bottom, you just put them in there. You don't have to do anything else and just hit enter. It's going to simplify it for you. And so it's 25 over 3. And that's the final answer. And you might say, well, how do I show my work? Well, I'm going to assume that you can use your calculator. Okay, so for this particular question, I'm okay with this. But if you had to go back and figure out, like, what did I divide by to get these numbers? 225 divided by something got me 3. The same number when I divided 1875 by it got me 25. You just work yourself backwards. So do 225 divided by 3, and that's 75. So if you check this, it should be the same. 1875 divided by 25, 75. So if you wanted to show your work, you could show that you divided by 75. But just know that the calculator is going to do it for you. And for some of you, that's where you really struggle, is just with the numbers, and that'll help you out a lot. So if we go to number 9, we got negative 4 on top with an n, 24n squared here. Now, first of all, I've got an n, it's like a 1, end of the first and end of the second. So this end of the first is going to cancel one of these. So I'm still going to have an n on the bottom. Okay, there was 1 on top, there was 2 on the bottom. Another way to think about it is this is just an n squared is n times n. So one of these n's cancels one of these, so I still have 1 on the bottom. And then 4 over 24, let's practice using that function. So alpha x, put 4 on top, 24 on the bottom, hit equals 1/6. Okay, so I'm dividing the top and the bottom by 4. Don't forget your negative. So it's going to be negative 1/6. And that's it. If you want to show me that you divided by 4, you can, but it is not required. All right, on to number 10. 10 over 15. That one we should be able to do ourselves. We don't really need the calculator, but if you needed it, you could use it. You got an n on the top and an n on the bottom. Those will cancel. M and p, they're not going anywhere. Nothing to cancel those two, so they are going to stay. And 10 and 15, you could divide them both by 5, and so you're going to get 2/3. So it's 2m over 3p, final answer. Okay, number 11. So on number 11, we have 1.2m over n times 1.2n over m. This is one I'd like to start canceling early. And so I have an m and an m. I'm going to go ahead and cancel those. Now remember, if they're both on the top, you don't cancel, you multiply. But one's on the top, one's on the bottom. So those cancel. And the reason they cancel is because I'm actually dividing m by m. So I'm getting 1, which I can just get rid of. And then n over n is going to cancel. And so all of our variables are gone. This is just 1.2 times 1.2. So I'm just going to multiply 1.2 times 1.2, and it is just 1.44. Final answer. Okay, number 12. Okay, this is another one where before I even multiply and worry about anything, I can cancel. X squared and x squared cancel. V and V cancel. 7 and 7 cancels. And so some people would put 0 or say no solution or something like that. But remember, we're actually dividing. 7 divided by 7 is 1. V divided by V is 1. X squared divided by X squared is 1. So my final answer here is just 1. Okay, 13. All right, again, I would like to cancel things early. I've got a B, and it's going to cancel one of these B's, which means I'm going to have 2 left over in my final answer. So I'm going to have a B squared down on the bottom. And this A is going to cancel one of these A's. So I had 2, now I have 1, and it's on the bottom. This C is going to cancel this C. They're completely gone. 4 and 2, that can simplify. Think about 4 divided by 2. You'd get 2 over 1 here. So I got a 2 and a 1. 3 and 27 can be divided by 3. So if I divide this by 3, I get 1. I divide this by 3, I get 9. Okay, and I can multiply straight across here. And so I'm going to get 2 times 1 is 2, and 9 times 1 is 9. And always double check, make sure there's nothing else to simplify, but that is good. All right, 14. So one thing that people get confused on now is they want to start canceling these ends, but we need to go ahead and just throw a 1 down under here so we don't get confused. The 2 ends on top, this end's on top. All right, so those are going to get multiplied together. Now you could go ahead and multiply straight across and simplify later if you want to. So you would do 2 times 3, you do n times n, which is n squared. You would do 4 times 6, so you're going to get the 24 and you're going to get the 6, and then you can simplify later. But I'm going to go ahead and get in the habit of simplifying early if I can. So I know 2 and 4 is the same as 1/2. Divide them both by 2. That's 1 over 2. And 3/6 is also, divide those by 3. You get 1 over 2. Okay, so across the bottom, 2 technically times 1 times 2 is 4. And on the top, it's all just 1s, so it's just n times n. So that's n squared. And that's done. Now, let's go back for a second. Let's try it where we don't necessarily simplify early. So straight across, you're going to get 6n squared. It's still n times n. And 4 times 6 is 24. And then you'd have to simplify the 6 and the 24. You divide them both by 6. You're going to get a 1 on top, which is right here. And then on the bottom, 24 divided by 6, you're going to get the 4 right here. And then we get to the same answer. So if you want to multiply first, simplify later. If that makes more sense to you, feel free. Or if you see things that can simplify or cancel early, go ahead and do it early. And then just get to your final answer without having to simplify any bigger numbers. Either way is fine. Doesn't really matter. All right, 15. So one rectangle is half as wide and 1/4 as long as another. How do their areas compare? 2 different ways you could look at it. You could look at it with a variable. So let's go ahead and make a rectangle. And let's use a variable. So x for the width, y for the length. And so if I made another one, it's technically smaller. It says the width is 1/2 as wide. So that would be whatever x is, it's going to be half of it. And it's 1/4 as long. So it's whatever y is, you're going to take 1/4 of it. So it's going to look like this. And if you're going to find the area of these, you're going to multiply length times width. So x times y. So the area of this is xy. And then here when you multiply 1/2 times 1/4, 1's on top, 4 times 2, that's 1/8 on the bottom. And then you're still going to have xy. And so you look at these, and it says, how do they compare? And so you could say something about this is 1/8 of the size. Now, if that confuses you, just dealing with all of the variables, you could put numbers in. But if you're going to do it, you need to pick numbers that make sense, or at least make your life easy. They told you that the one rectangle's width is half as much, so don't pick 9 where you got to take half and it becomes a decimal. Okay, pick an easy number, like let's say 10. So that means if it's half the size, it's 5. So if x was 10, 1 half times 10 is 5. And now we're going to take a fourth of something. That's like dividing by 4. So pick an easy number. So I'm going to pick 8. 8 times 1/4, or 1/4 of 8 is 2. Now the area of this is going to be 80, 8 times 10. And the area of this is going to be 10. And so how do their areas compare? Again, this is 1/8 of the size. So you can look at it with real numbers, or you can look at it with variables. Either way is fine. All right, we're going to go to 17. I'm going to start this one on a new page. All right, these two families have rectangular vegetable gardens. The length of the one is 2/3 and 3/4 the width, so very similar to what we just did. I'm going to go ahead and use variables for this one again. So I'm going to call this one x and y. And for the other one, they're telling you that the length is 2/3. Now, it doesn't matter which one you call length and width. So I'm just going to go ahead and put the 2/3 right here. So it's 2/3 of x. And then the other one